the Pythagorean theorem. So the first thing that we want to do with the Pythagorean theorem is understand the different parts of a right triangle. So with the Pythagorean theorem, this only works with right triangles, and with right triangles we know they have one right angle and two acute angles. They could be obtuse, they could be isosceles, or they could be scaling. Now the different parts of our right triangle are our two legs and our hypotenuse. The two legs come together to form a right angle. And the hypotenuse is the side that's across from your right angle. So this side right here, this is the hypotenuse. The hypotenuse will always be longer than either of the legs. The hypotenuse will always be longer than either of the legs. In all right triangles, the sum of the squares of the two legs equals the square of the hypotenuse. So the two legs make the right angle, and the side opposite the right angle is the hypotenuse. Oftentimes the legs are labeled with A's and B's. It doesn't really matter which leg is A and which leg is B. And the hypotenuse is labeled with a C. So as I mentioned, the square of the two legs added together will equal the square of the hypotenuse. C will always be greater than A, and C will always be greater than B. In other words, the hypotenuse will be greater than either one of the legs. So let's name the hypotenuse in each of these triangles. So B is the hypotenuse in the first triangle, X is the hypotenuse in the second, and K is the hypotenuse in the third, because those are the sides that are across from the right angles. So in this diagram, we have a right triangle in the middle in purple. Now we have each length of each of the sides squared coming off of them. So for example, at the bottom here, we have a length of 3 for the length of that side of our triangle. And what's the area of the square beneath? 9. Then we have a length of 4 for the other leg. So what is the square off of that? So the square off of that is 16, or 4 squared. So then look at the hypotenuse. Figure out the length of the hypotenuse and figure out the square of that hypotenuse. The length of the hypotenuse is 5. 1, 2, 3, 4, 5. And then the square of that is 25. So you'll notice that if you add the square of the legs, so the square of the leg that's 3 gives you 9. The square of the leg that's 4 gives you 16. If you add 9 plus 16, that gives you 25. Well, that's the square of our hypotenuse, because 5 squared is 25. So the squares of the legs equals the square of the hypotenuse of the lengths of the sides of your triangle. So that brings us to the Pythagorean theorem, which I mentioned earlier. It tells you the sum of the squares of the legs equals the square of the hypotenuse. The way that we write this is a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Again, it doesn't matter which leg is a and which leg is b. So this leg could be a and this leg could be b, or vice versa, but the hypotenuse is always c. And a and b are the lengths of the legs, and c is the length of the hypotenuse. But when you square the legs, it'll equal the square of the hypotenuse. So in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. Which of the following triangles could we use the Pythagorean theorem with? So we can use the Pythagorean theorem with any triangle that is a right triangle to solve for a missing side if we know 2 of the sides. Is this triangle a right triangle? All you have to do is square 2 of the sides and see if it equals the other side. But which side is C? How would you know which side is C? Because you have to know which side is C and which 2 sides would be A and B when you're looking at the 3 numbers. So when we're looking at the 3 numbers, the longest one's the hypotenuse. So you're going to say the 2 smaller ones squared, add them together, and see if that equals the bigger one squared. Yes, this is a right triangle. I can tell because 10 squared equals 100. So that's the square of my hypotenuse. And then for my two legs, 6 squared is 36, 8 squared is 64, and 36 plus 64 does indeed equal 100. These are the steps you would show. And the idea is the square of the legs has to equal the square of the hypotenuse for it to be a right triangle. This will work for all right triangles. Try this one. Is a triangle with side lengths 12, 8, and 8 a right triangle? So our two legs are 8 and 8 that are, because they're smaller than the hypotenuse. The hypotenuse is 12. 8 squared plus 8 squared is 64 plus 64, and that equals 128. 12 squared is 144. 128 does not equal 144, so this is not a right triangle. Here's another example where a triangle with side lengths 12, 13, and 5 is indeed a right triangle because 5 squared plus 12 squared does equal 13 squared. Not only can you test to see if a triangle is a right triangle given the three lengths of the sides, but you can also solve for a missing side by using the Pythagorean theorem. So we know that a squared plus b squared equals c squared, where c is the hypotenuse and then the other two are the legs. So we can just substitute the numbers into our formula and solve. Go ahead and try that. All right, so we're going to substitute the lengths of the sides in the place of our formula. And when we do, we get 15 squared plus 20 squared equals x squared. We're solving for the hypotenuse, so the x goes in place of c. Or you can put a c there, it doesn't matter. 15 squared is 225, 20 squared is 400. We're going to add those together. We get 625 equals x squared. We have to take the square root of both sides of our equation in order to solve. And then you can just put that in your calculator. The square root of 625 equals 25. So the length of x is 25. So now find the length of x. Notice that in this case it's a leg, it's not a hypotenuse. Make sure you substitute your numbers into the formula and show all your algebra. So the first thing you do is your substitution step. It doesn't matter if you let x be your a or b in your formula. Then you square everything. So 5 squared is 25, 8 squared is 64. Then you need to add negative 25 to both sides to get that x squared by itself. So when you do that, you end up with x squared equals 39. Then you're going to take the square root of both sides, and you end up with x equals the square root of 39. And that's the most exact answer. X equals the square root of 39. And if you put that in your calculator, you get 6.2. So we can apply the Pythagorean theorem to real life, which is the whole reason that we use math, right? So the distance from Raleigh to Statesville is 210 miles due west. The distance from Statesville to Woodlawn, Virginia is 340 miles due north. Find the distance from Raleigh to Woodlawn, Virginia. So the first thing I would do is draw a picture. Seeing as how we're dealing with triangles is probably going to form a right triangle. But why don't you draw it and see if it makes sense to form a right triangle, and then solve. So here's my picture of the right triangle. If we're going due west, that means we're going exactly west. And then if we're going due north, we're going exactly north. That helps to set up the right triangle in this picture. And so we can use the Pythagorean theorem. And we're going to substitute the distance from Raleigh to Statesville is 210. And then from Statesville to Woodlawn is 340. So that's the legs in our triangle, in our right triangle. We'll put that in our formula, and then we square. We get 44,100 plus 115,600. Simplify. We get c squared equals 159,700. Take the square root of both sides. We get c equals the square root of that, which is 400 miles. So the distance from Raleigh to Woodlawn is 400 miles. The distance from a flower to the bottom of a tree is 12 feet. The distance from a flower to the top of the tree is 43 feet. Find the height of the tree. So in this case, we are solving for the height of the tree, which is the leg. So we have a squared plus b squared equals c squared. And We know that one of the legs is 12 and the hypotenuse is 43. So we square 12, square 43, and solve from there, and we end up with 41.3 feet. A ladder that is 6 meters tall is 2.5 meters from the base of a wall. So you would want to be able to draw that. If the ladder is leaning against the vertical wall, how high up does the top of the ladder touch the wall to the nearest hundredths? So this is what the picture looks like when you draw it. Although it doesn't have to be quite that neat. So we're looking for the height of the wall. Here's our ladder leaning against the wall, and we're looking for where the ladder ends up touching on the wall, basically. And here's the distance from the bottom of the ladder to the wall. Here's the actual height of the ladder, and we want to see where it touches the wall. So we are looking for one of the legs of our triangle, and we plug in 2.5, which is one of the legs, 6, which is the hypotenuse, into our formula. Square 2.5 and 6. Add the opposite to both sides and solve. We get x squared equals 29.75. Take the square root of both sides, and x equals 5.45 meters. Find the length of the diagonal in this square to the nearest hundredth. Now we know a diagonal connects opposite vertices in a polygon. That's one of our definitions. Well, when it does that in this particular polygon is it's a square. It tells us it's a square. So all the lengths of all the sides are the same. So we know that we have a triangle where two sides, two legs are 10, and the hypotenuse, which happens to be the diagonal, is what we're solving for. So we're going to put in 10 and 10 in the place of the legs and just solve from there. And we end up with c squared equals 200, and the square root of that is 14.4 meters. So the length of our hypotenuse, which is the diagonal of the square, is 14.14 meters. In a rhombus, the diagonals are perpendicular and bisect one another. So that means that they form a right angle and they cut each other into equal segments. Okay, so this is important. If the diagonals have lengths of 12 and 18 centimeters, find the length of one side of the rhombus to the nearest hundredth. So let's break this picture. So we know that the length of one of the diagonals is 18. It doesn't matter which one. We know the length of one of the others is 12. Again, it doesn't matter which one. Since they bisect each other, we know that the one that's the length of 18, each half of it is 9. And the one that's the length of 12, each half of it is 6. So that means that we have a triangle that is formed, a right triangle, since they are perpendicular to each other. This forms a right triangle. And the right triangle is right in here. So we have a length of 9 and 6 forming our right angle, and we're looking for the hypotenuse, which is one of the sides. So we substitute 6 and 9 into our formula. We get 81 plus 36 equals c squared. Take the square root of both sides, and c equals 10.82 centimeters. So that's how we solve for the length of one side of our rhombus. I can't remember. You'll have to look on the website. I think it's just, let's see, let me look real quick. I've got it right now. Evens, you guys are doing the evens.
Did we get homework published?
I didn't check homework today. You're welcome. You're welcome.